Right, hello there and welcome. I've no idea how long this is going to last, probably an hour or so, but let's see how it goes. But yeah, make it as interactive as possible. If you've got questions, please either drop them in the chat or unmute yourselves and ask them. So I'm probably not going to be able to see the chat necessarily. So PowerShell performance pointers. What am I on about here? Well, not pointers in the C++ sense, but things you can do when writing PowerShell to make them faster. So just a little bit about me first, really just to set the scene. My background is as a developer. I wrote my first program over 40 years ago. Yeah, quite a while. I've been doing Windows stuff since '95. And my day job these days is typically writing PowerShell, although I do bits of C++ and C# for software vendors like the ones listed there. And because of my work in the community, sort of giving scripts, helping people, doing presentations like this, various vendors have seen fit to give me various awards, which is nice as long as I have stickers with them, because I'd do anything for stickers. So first slide, is performance important in your script? Not usually. Okay, well, that's the end then. Yeah, no more to say. Well, okay, let's go a bit further into it. It's nowhere near as important as actually making the script work. I put a post, I think, or a comment somewhere today when somebody said, well, yeah, I've done this. It's not pretty, but it does the job. And I said, absolutely well done. Yeah, that's the main thing. Get your script to do what you want it to do. If it takes half an hour, great. It doesn't matter. Who cares? If you're running it every 5 minutes, it takes half an hour, you might have a problem. But yeah, the length of time it takes doesn't matter as long as it's correctly doing what you set out for the script to do. And saving 10 minutes in this sort of instance, does it really matter? And how long is it going to take you to save those 10 minutes anyway? So I'm trying to talk you out of optimizing your code. And certainly one thing I'm not really suggesting is, unless something is time critical, don't go back and optimize existing code. Just learn some performance tips. The few times I've revisited code is when I've done scripts for vendors and it's taken perhaps 15 minutes for a script to run, which the vendor said, no, that's really too long, can you make it quicker? So I've looked at the code, and I'll show you some of the tools I've used shortly to make it run faster. One thing to note is making scripts run faster may come at a price. If you're making your script run faster, it might take more CPU. Now, if you're running that on a end user facing IIS server or SQL box or Citrix or VMware, then that could take CPU cycles away from the end user facing services. So I tend to use what we tend to call a jump box, which is just a server somewhere that people can RDP into and has got all the SDKs, APIs, consoles, etc. that you need, so that you can put everything in one place. And typically where I'll set up scheduled tasks as well for PowerShell and other maintenance jobs. So the key is really not to revisit old code and make it faster, but think about performance when you're writing. And then there's a lot of tips in here for that. And again, I'll make the slide deck available afterwards. Hopefully there'll be a recording available afterwards as well. So when you've forgotten what I've said, which for me will be in about 10 minutes, what was I saying? Then you've got something to refer back to. Some of the key simple things, which I didn't want to put in a slide of their own, are expressions. So if you're doing an if, so let's get a PowerShell prompt. I'll use Windows Terminal because I'm so modern. This is PowerShell 7, I think. Yeah, but it doesn't matter. Again, 7.2 released yesterday or the day before. Again, what I'm doing here will work in PowerShell 5 as well. And oops, don't forget to type a few more characters before your tab completes. It doesn't really matter. So what do I mean by evaluating left to right? So if you're doing a if something, so let's set a name equals guy. Let's set names equals, let's make it an array. It's already told, so we can see from the highlighting, I can't actually match my quotes. So we've got names. So I could say, you know, if $, and again, I like putting spaces around things because it just makes it easier to read. So I might say, well, because names could be null. So if I started looking at, you know, names 0, names as null, I might have a problem. So I might say minus names minus, yeah, and $names minus contains guy. Because if names is null, it won't even get round to that. So again, this is a trivial example. What I'm saying is, you know, with an if statement, everything is evaluated left to right. So if you've got an and, if this is false, then it won't go on to the next condition. So if you've got something which is quite compute intensive, so you might have something here which, you know, contains, if it's a large array, might be quite big. So you might want to not do that if you have something else is simple. So if, let's say, if we don't have a input name, so we've got nothing to match, I would say, you know, if we don't have anything to match, and rather, no, sorry, let me put it down. It's going to be easier, isn't it? Oh, and let's do some strong typing as well. Name to find equals guy. So what I mean is something like this. If, again, we'll do a not string. Use a lot of this is null or empty. $name to find contains name. This is a much better example. There we go. That's better. Obviously, the guess stuff is just what you replace with some code. So what I'm saying here is, for efficiency, if I haven't got a name to find, then I'm not going to bother looking for it in the contains. The contains might be optimized to not iterate over every item in the array. I've only got 3 here, so the overhead's not great. But what if I've got 3,000 and I'm looking for a name in it? Well, if I haven't got a name, don't bother searching, because if that is false, then the and won't even be reached in effect. So that will not be evaluated. So put your simpler expressions to the left when doing an if is the upshot of that one. And similarly with an or, yeah, again, as soon as something evaluates to true in an or rather than an and, then the whole if statement will be true. So just bear those in mind. And this old classic, again, which is, you know, filter as far left as possible. What do we mean by that? Well, again, if we, let's click the screen. How's the font size, by the way, people? Can you read this font okay, or do I need to go bigger? Everybody's not listening. No? How's the font?
It's
okay,
it's okay.
It's okay. Yeah, you're
okay.
probably not all as old as me with failing eyesight. Okay, so, or you say what text? Okay, yes. Okay, we'll use that font size then. Again, good old terminal, so I can just do a Control+ to zoom in. Right, PowerShell slides are mainly to remind what to talk about. Filter as far left as possible. So let's say we're looking for a process. So what I could do is I could say get process where name minus equals PowerShell, for instance. Yeah, but what that will do is get all processes back, which is actually 507 on my Windows 10 laptop. Yes, I'm living in the past on Windows 10. But what we could do is, you know, get process minus name, which moves the filtering over to the get process. So that will only return, again, we can actually tab complete this, will only return 5 instances. So that's what we mean by filter left as far as possible, because we're getting fewer objects. Therefore, whatever is on the to the right hand side, which typically for this sort of thing is going to be some more complex code than measure object, has fewer objects to work on. So it's going to use less CPUs, less memory. Yeah. So make sure you investigate any filter options for, if you're using something like get Kim instance, then you can use a minus filter. So if we do a minus class win32 underscore process without the double N, minus filter, we can say name equals PowerShell.exe. And then we're just pulling out so we're just pulling out 5 because the get Kim instance is doing the filtering. We're not then doing, piping it through a where object. So it's just, these two sort of things, just always bear in mind whatever code you're writing, always do it that way wherever possible. You can't always filter because not everything has a filter built in, or not everything has a filter which is good enough for what you need. For instance, with the get Kim instance here, we've got a name, we can have name like, but we can't have regular expressions. So you might want to combine like with a regular expression, do some filtering and then filter further to the right if you need to. Okay, so how do we measure performance? Do we sit there with a stopwatch? Well, that is one way of doing it, definitely. Measure command is something we can use. So I can wrap anything I want inside that. So if I do a measure command, and it takes a script block argument, then we can see how long that has taken, 439 milliseconds. I mean, we can compare that with writing it this way. With a hash, we can't go. Oh, look at the state of this keyboard. I must get it replaced. It's not me, honestly. So, whoa, 50 milliseconds difference, 10%. Oh, yeah, great. But that's one. Yeah, that's one instance of calling it. Once is not enough. Yeah, because we don't know what else has been going on in the system. We need an average. So we could do it. Let's do it 5 times. Let's do it 10 times. So a quick way to do it 10 times is like that. And I could do it for each object. But what I'm going to do is to use the % alias for it and match up my braces. Don't use things like % in scripts, always put for each object. But when you're doing things in this immediate mode, it's okay to do that. We don't do it in scripts because it makes it harder for people to understand, particularly when they're not necessarily PowerShell literate. So we can do it. What's that? Yeah, that's kind of scrolling off the screen. So let's just grab the total milliseconds. Again, good old terminal means I don't actually have to right click that. So we'll do measure command pipe select minus expand. So you can see there, you can see they're quite different, and we could actually even type it through measure object and take an average. Of course, we won't get any output till it's finished. So it's telling us as a count, and the average was 388. Yeah, I'm not going to bother comparing that with the filtering here. Again, what I'm really showing you here is how we use measure command to see how long something has taken. So I would do at least a minimum of 10 iterations. And again, when we've got something less than a second, it's very variable, as we can see. So you probably want something which took longer. If you're trying to optimize something which takes half a second anyway, I think unless you're doing that a million times, you're kind of wasting your time. Yeah. And if you're doing things with a file system, for instance, you say, right, I'm doing this search across these files. Oh, the first one was slow, but the second one's really fast. Maybe it's cached, the directory listing and all the contents of the files in the file system cache. you have to then take measures to clear the cache to make sure you're, as we say in English, comparing apples with apples, comparing the same thing, and it's not some external factor that's causing the problem. But measure command can be quite useful. Poor man's measure command, and that's all measure command really is doing, is getting the date difference. So if you're doing a block of code, then you would just do a, again, I had a falling out with a few people on Twitter because I always type define my variables, because some people might say, well, if you're calling get dash date, then that's obviously going to be a date. But because I come from a C++ or in fact C world, where you have to define the type of everything, that's just what I do. Then we can do our and then obviously I'm not doing this very well because this is manual. So what I would probably do is you do something like, and again, I'm going to drop, for the sake of time, just drop typing in the type again, because it's immediate. Start equals get dash date with $. So we can see $start and $end actually look to be at the same time, but because they're actually recorded with much more granularity in that, I can actually say minus $start. Control delete and control backspace, by the way, to delete word forward and word backwards. Saves having to hit backspace multiple times. So you can say, oh, that looks like a measure command output. Yeah. So that's another way of doing it, rather than having to wrap everything in a measure command block. So quite often in my code, when I'm just writing it initially, I don't want to have lots of measure command stuff around it, because I don't want measure command in the final output or in the final script. So I'll just get dates at various points and in write verbose messages so that they're not there in production. If you don't use mine as verbose, will tell me what the runtime is. Another way we can do things is with this stopwatch, if you've ever used it. Quite useful for timers. So let's see if I've got one I prepared earlier. Yeah, here we go. Again, using PowerShell's persistent search history there, I use Control-R and just typed a few letters in. You can see I typed in diag, and it brought me back to the lines I typed in earlier when I was just preparing my demonstrations. You see I do some preparation for these things. So that's going to define a new stopwatch using the .NET Diagnostic stopwatch. So we can see $stop at the moment isn't running. I can create one and start it straight away. I can see we've got various methods. So you can see in terms of methods, we've got start. So I can do a start, again, tab complete. And we can do that, and then $stop. Stop. Obviously, again, I would do it on the same line or the same lines of code as I did with the get date, because obviously we've taken into account here my ability to or inability to type. But now if we look at $stop, we can see elapsed ticks and elapsed milliseconds. So we can actually see, it took 10.5 seconds. Divide that by 1,000. So that's how long it took. So I tend to use those in retry loops, because if you're doing retries for code, let's say I've done a lot of REST work recently with Citrix and Azure and VMware. So it might be I need to recall a method or a REST endpoint that previously failed or didn't give me the right answer. Let's say I'm polling to see if an operation is finished. Then, okay, so it's like, let me bring some code up. Got lots of code here ready for demonstrations. Too much code, so I can't find the one I actually want. Let's have a look at this one. Various scripts I'm working on at the moment. There, so here we can see a retry loop, which has got timers around it. So you can see I can actually create a new timer and start it all in one, rather than having to the new and the explicit start. So what I'm doing here is seeing if I can connect to a specific port. I tweeted this out a couple of days ago. If you use test-net connection, which I use a lot to see if you can get to a port on a given IP, that can take 20 to 40 seconds to come back if the port isn't open. whereas using this method, which is actually what testnet connection uses, will come back in, well, here, whatever millisecond duration I specify. So rather than having to worry about how long I'm sleeping for and how long this is actually taking, you know, because you might say, well, maximum retry count is 50, but depending on whether I'm sleeping for 500 milliseconds or 5,000, you know, that retry count of 50 will take different amounts of time, 10 times, in fact. So what I tend to use is timers for my retry loops. So that's one of the reasons I use stopwatches, but they can be used also for timing how long code takes to execute, but very useful for retry blocks. And then a bit of self-plugging, but it's worth it because, again, this is a nice implementation in PowerShell if I can find it. So we've got a clock. So if you do something like what I've got here, like I say, mark. So let's say, you know, clicked go button, and I'm waiting for something to happen, and then, oh, it's happened. I click mark again. It happened. So I've now got exact times of when these things happen, and I can actually save these, edit them, export them, etc. I use this a lot when I'm doing stuff, particularly when it's visual and I can't necessarily wrap the code. So if I'm timing how long, for instance, it takes for a Citrix connection to launch, and when I click on an icon in a browser to when I get something on the desktop, then I can use this to make notes. So as soon as I hit mark, it puts the time the mark button was pressed in the time here. So I've got the leisure of typing in, and it's going to have the right time. So again, that's on GitHub if you want it. It will also do a countdown timer, which is normally what I use if I'm under the clock for things. So I can actually then say, oh, let's start running that. An example of using a PowerShell GUI. Not the greatest of GUIs. I'm a command line person. You know, I started my coding career, like I say, in the 80s when green screens were the thing. But that's my clock. And this particular project from fellow MVP is very useful, the PS Profiler project. And let's see, I think I've got it loaded in here. So I've previously loaded it. This is kind of a running joke within that sort of community. Why script no go, as in why is it not running? Which is just an alias for the measure script. But the measure script will tell us, and using Control R to search. This is not a great example because it's one line, but this gives you an idea of what it will do. It will tell you each line number of your script. So if you wrap it, you can give it a path to a script and an argument list of arguments to pass to that script, and it will give you a line by line timeline, which you can pipe into something like Outgrid View to give you an idea of what your slow parts are. Where's it spending a lot of time in the script? So you actually don't have to guess. So this is really, really good stuff. I use it a lot for trying to find the slow parts in my scripts. If I can't figure out where they are just by code inspection. Typically if I know I've got a loop where I'm iterating over 100,000 items, then that's probably where I'm going to focus my efforts. But that's a great PowerShell module for just giving you an idea, particularly if you're using somebody else's script and it's quite long, then go to PS Profiler. Loops. Well, loops are the thing which can take a lot of time. So let's talk about how we can optimize and show, of course. I don't actually know where the PowerShell or where the chat for this is. Let me just bring that up just in case. Good, no chat items, but feel free to interject or ask questions. And I'll be available on Twitter later anyway. Okay, this I see a lot because I pick up a lot of other people's scripts through my various roles. Other people send me scripts, asking me to improve them, or I pick them up as part of my work with the vendors. So one of the things that people forget, or perhaps don't realise, is if you're doing a loop iterating it 1,000 times, why would you set the same thing 1,000 times within the loop? Yeah, so if I've got let's start a new script. So let's say $items equals get child item path. Then I might have that, and so I might say, now I might pipe it through for each object, but we'll come back to that later. $item in $items, string $path of interest equals of gold with $item minus match interest. Yeah, okay. It's a little bit contrived, you might say. But what I mean is, we're doing that in here, and that's a string literal. It's probably not too bad. But what if it was, let's say if it was a size, which is, 32 gig. Now you might say 32 times 1024 times 1. No, I don't mean 1,000. I mean 1024, or 1024 even. Of course, we can actually say that as 32 gig. Yeah, 32 gig we can use in PowerShell. But it still has to work it out. Yeah, it still has to, So we could say size minus greater than equal to, let's change that to, again, control backspace to delete the whole word, size, that sort of thing. Or, perhaps we lose then, it's too big, too big. What I mean is, do that. Yeah, so this is a trivial example, but if you're doing something multiple times, why would you do it inside each loop iteration? Yeah. Only calculate things, set things within the loop that are actually changing within the loop. And we'll come on to actually caching on a separate slide later, particularly if I'm getting objects from, let's say, Active Directory. So I want to check these users that I've been given in a CSV, do they exist in Active Directory? Do I want to keep calling get AD user if I've got the Active Directory module? Well, we'll come on to a separate slide about that in a bit. Now, whilst we're trying to make our script run as fast as possible, we've got to consider things the other way around as well, which is, what's the impact on the machine? Hopefully, again, as I said earlier, not a production machine, so that we'll put it on a jump box, but that jump box might be on a virtualized host, ESXi, or whatever else, so that if that's taking a lot of CPU, that's potentially CPU not available to other VMs. So in your script, let's say you're checking the status of something. So I was doing some REST API work with Azure today. I issue an async command to go power off and deallocate this VM, which comes back and says, yes, I've started it, but I need to keep polling for the results. Do I poll without a sleep in it? So I'm going send request, send request, send request. Or do I go, well, I'm going to sleep for 2 seconds just to put a less impact on the machine, on the network connection, on Azure, because again, there are rate limits for certain things. So just because your script wants to be as fast as possible, think about the impact on everything else. You could actually reduce the process's base priority if you wanted to, just to reduce the impact of that script. So this is not making it going to run any faster. I mean, you could set the priority higher. So it could be, you could set it to above normal. The beauty of these, if you know about Windows process scheduling, is that if you set it to below normal, but if nothing else needs the CPU, then your process will get the CPU anyway, and it probably won't be negatively affected runtime wise anyway. But you can mess about with priority classes if you want, as long as you've got rights to that process. So if you're not an admin, you can only change your own processes. I wouldn't go for real-time priority though if I were you, particularly if you're going to write something which is doing a lot of processing, because that could mean nothing else on the system gets a look in. Although, again, these days with multi-threaded processes or multi-core processors, you'd probably be okay, again, unless your process is multi-threaded, which we'll talk about later as another way of making things faster. I see this quite a lot as well, that people will run a loop to get something, and then they'll run a loop again over the same set of objects doing something different. Why don't you combine the operation to do everything in the same loop? Yeah, so if you're looping over the same objects, particularly if you copy and paste a block of code, and then once you've pasted it, change it slightly, that rings alarm bells in two ways. First of all, because of this repeating the looping, if it's a loop construct, but also the fact, should it actually be a function? Now, if you, golden rule generally, if you start copying and pasting chunks of code, where a chunk of code is half a dozen lines or more, then it's probably about time you put that into a function so that you can just call it once, particularly so that if you need to fix it, then you only need to fix it in one place. Yes, there is an extra overhead of calling the function compared with having the code in line, but that's a small price to pay for being able to update it in one place. As if you found a way to make it a lot faster, then if you'd copied and pasted the code, you'd have to change it in every place where you've copied and pasted it. Again, particularly if you're outputting this stuff to a screen, particularly on a remote session, do you really need to put a right verbose out? So if you're iterating over 10,000 accounts in an Active Directory, would you put a right verbose out for every single account? Well, you might need to, depending on what you're doing, but you might then have some logic in the code saying only do every 10. You just have a counter in there, and if the remainder divided by 10 is 0, then you put a right verbose message out, doing the next 10 or doing the next 100. But again, don't hard code it. Make that 10 or 100 a parameter to your script with a default value. As I was saying before we started the recording, a lot of my scripts have parameters which you'll probably never use, because there'll be parameters like that where I put in a sensible default, but if people want to change them, they can change them by specifying different parameters rather than by changing the code, because you really don't want people to go in and start trying to change your code, particularly if they don't know what they're doing, because they're probably going to break it, but then they'll still come back to you and say, well, you wrote this script and it's not working. What have you changed? Nothing. Which again is a reason why I digitally sign a lot of the scripts I put on GitHub, so at least I know if they've been changed. So just ask yourself that question. Don't use a lot of write progress, but sometimes it can be useful. This is one that not a lot of people seem to know about, and I only came across it a few years ago. Although, to be honest, PowerShell I've only been doing since about 2014, whereas PowerShell itself is a teenager, so it's about, what is it now, 13, 14, 15 years old? I wish I got into it a long time before that. It was usually a case of, oh, I need to do something quickly, right, I better do it in VBS. I haven't got time to learn PowerShell. So I only learned about this where ability over where object. So let me tell you what I mean here. So here's the screen. Let's get an array. So let's get, again, I'll strongly type it because that's the way I roll. Even if I can't type, equals get child item. I could, of course, use ls or dir. Get child item. I will just use where I am, for instance. I'll come back to this later as well, but when I want an array, I will always wrap it in these characters. Why? Because that forces it to be an array, even if it's only one character, one result, sorry. Because PowerShell's got this built-in feature, which I mentioned later, of flattening arrays, which are one item, so it's not an array, which can be useful, but also can be very confusing at times. So if you want an array, using the @ character and the bracket forces it to be an array, even if there's only one object. But because in my demo folder, there's going to be lots of files. How many files? 139. So let me find all those that have got my name in it. So what I could do, for instance, is pipe through where, which we know there's an alias for it. Again, don't use that in a script because it makes it difficult to understand. So we're going to have where or where object. I'll type it full. Again, tab completion doesn't make much difference. Because I'm using PowerShell 3 and above, I don't need to use the curly braces for simple expressions. I do if I'm using ands and ors, but for a simple expression, I can just say name minus match. And I'm going to use one of those scary regular expressions. The regular expression to see if it matches Guy is Guy. Ooh, scary regular expression. Yeah, and I've got 5 files which have got Guy in the name. Yeah, okay, so I should have said, I've done that. Yeah, but again, I'm just trying to show you how we use the where method. You can obviously apply this to any type of collection. Let's clear the screen. So we've got that. But what we can also do, if we look at the methods available, so our get method, or GM for short, and it doesn't show us that. It's still -4. Does it show us that? No, it doesn't show us the where. That's good, isn't it? Because what we have is, let's just get the previous one up. We have $files, if I can type it right. We have a where as well. So notice that's a method. Yeah, so I'm not using a pipeline there. I'm calling a method on the array. So that's an array. So all collection type objects, of which an array is one, have a where method. And what I can do there is I can say, now I do have to use the $_ to represent the current object, like I used to, or like I would if I used the curly braces up here. So I say $name minus match. Line again, by default, PowerShell match operator is case insensitive. If I want it case sensitive, I can do a C match. And that's doing the same thing. Now, of course, what we could do is wrap those in measure command to see which is the fastest. But my tests have shown generally the .where is faster, particularly for large collections, because you're calling a native member rather than, there's always an overhead when you set up a pipeline. Pipelines are good in some ways in PowerShell. You can pipe the output of something into the input of something, into the out, and then into the input of something else. You can have very long, one-liners, which I generally hate because they make it very difficult for people to understand. But sometimes they can be the fastest way of doing things. So I'm not totally opposed to them. But if it's clarity over speed, then I'd break that into multiple lines. The advantage of pipelines generally is whatever's on the left doesn't have to complete before the right-hand side starts operating. So what we're doing here is calling that method with a statement script block to say when the name matches Guy. So we get the same results, but I say we're calling a member function here as opposed to setting up a pipeline and calling the where object commandlet. And we can do various other things as well. So if I only wanted one match, I could say (1). But what if I wanted the last argument? Well, I can. Again, this is covered later in the slides as a reference to it. This is actually an enumeration in .NET, but it forces it to the enumeration type. So I can actually say get the last, which we saw before. There's the last, there's the first. So there's a number of different ways I could do it. Whereas, yes, I can do that with the where object. Now let's make the where object look similar. So, and again, actually using it without the curly braces, last time I did some tests, is faster, obviously because the interpretation time is quicker. So if you're using PowerShell 3 and above, which hopefully you are, although sometimes by one of my employers I get shouted at if I do write something which isn't PowerShell 2 compatible, because their customers still have Windows 7 and 2008 R2 where they've never updated PowerShell, believe it or not. But hence why I'm not using a lot of PowerShell 7 in my scripts of customers. So if possible, use the original form of this where I didn't have the curly braces. And then I can do a select. Again, select is an alias for select object minus first one, or I could do the last one. But notice here, this method, I've got two pipelines now. So I've got the files piping the where object and then the select object, whereas here it's actually all within the same single method call. So that can be faster. And with the select, I can skip some as well. So I could skip two, but I can do the same with the .where method. We've got various other words we can use as part of the enumeration, like until and skip and so on. So that's quite useful. So I'd suggest, if you don't know about that, to go and look in the references slide, which again, I'll make this slide deck available via Twitter. Has a reference to a great article on the where method, if you've not come across it. Again, you can put compound expressions within that where script block with ands and ors, remembering, of course, to make sure if you've got a mixture of ands and ors that your logic is right and you put brackets around so your evaluation is correct. Another gotcha. If in doubt, put brackets around stuff. Yeah. If you're not sure the order of execution, put brackets around things. Sorry, excuse me. Okay. And guess what? There's also a dot for each on collections as well. So there's actually 4 different ways we can do things in PowerShell when we're iterating over something. So for instance, I could do a for each $file in $files. If file .length greater than 10 megabytes, underscore is big. God, what is up with this keyboard? It's terrible today. Well, isn't it? Yeah, $_. Yeah, I'm iterating with $file. Yeah, so let's put $file in there, shall we? That's a bit better, isn't it? Let's see. Even the no, I won't even say great. Even though they're supposed to know what we're doing, make mistakes. Yeah, just learn what a mistake is and move on. So that's me just using a for each file in $files. But the downside with that is I've got to have got $files before I've finished. So if $files is every single file on my file system, then I'm going to have to wait for the enumeration of all of those files to finish before I could start. Whereas if I do something like an alias for get child item, I just want to work on files, which is a PowerShell 3 feature or above. I can do for each object without the K in it. And I'm going to use line continuation character because that's the way I roll, even though I didn't roll on the previous one. So yeah, thing to be is consistent in your PowerShell, as I'm not being here. But yeah, certainly in your scripts, be consistent in the sort of the style and the way you do things, the way you name variables and so on. But that's more of a different session. So let's take this code. Again, because it's Windows Terminal, I don't have to right click and copy. Now I do need to change this to $_ because $_ is the variable that's in this loop. And again, it's prompting me because I haven't closed the curly brace. So you can see now, it's showing more because I didn't iterate over subfolders as well before it was big, and I probably ought to put the size out, but we can see what this is doing is as soon as it gets a file, it pipes it into the for each object. And this is actually a minus process block, because if you're aware of advanced functions, you have begin, process, and end. So that's 2 ways we can iterate over something. Now, if I've already got the files, I can say dollar without the percent. So we've got for each again, and this will. If I still put that in the clipboard, oh, look at that. Well, my luck and judgment, of course. And again, I need to change it to dollar underscore. And this does have to get the whole collection back before it can start working on it. But the advantage is here, again, we're using a method rather than setting a, where are we? Rather than using a pipe as we were doing here. So similar to the for each. So again, I tend to use .for each. Again, it's going to work on any collection. So if you've got other collections, again, we'll come up to arrays later because arrays bring their own interesting challenges in with performance, particularly when they get large. So again, it's worth getting into some good practices when you write any sort of code with arrays, so that if it does scale up, then your code isn't going to slow down massively. And then there's this one as well, which this dot process. So we're basically creating a script block implicitly, and rather than a begin or an end, we're doing a process. Now, I forget where I read about this. Again, I read about this a long time ago, probably in a galaxy far, far away, and it gave some examples of how much faster this can be. So it's more difficult to read, but what we can do, so if we do why don't I find it sensibly? I'll change what I've got here. So what we're saying here, if I get this right, is I'm going to sort of execute a script block, and in that process section of the script block, I am going to run the if length. Then I think I need an extra curly brace, possibly another one. No, got that wrong. Well done, guy. You knew these live demos are going to come crashing down at some point. Oh, yeah, I've got too many curly braces there, haven't I? I didn't need the line continuation. Oh, I did need the line continuation, but I didn't need that one. And I didn't need that one. Go on, that'll fix it. Oh, it did. Oh, perhaps I do know what I'm talking about. So that's yet another way of iterating. And if I can find the reference for it, it'll be in a script somewhere, because if I borrow any code from anywhere, I will generally put a comment in to the source of that, so people don't think I've invented it myself, because I don't want to claim I have. But I can't remember where I got that from. But again, I did find for certain things that was a lot faster than a for each object. I forget the reasons, but if I can find the article, I'll put a reference to it in this slide deck before I push it out on Twitter, which I'll try and do tomorrow anyway. So that's something I don't use very often, but can be very fast. So that's loops. Good old plus equals. Plus equals, what does that do? Well, that assigns something to whatever is on the left-hand side. What do you mean, Guy? Well, let me demonstrate. Again, let's clear the screen. String name equals Guy. Dollar name plus equals each name. Yeah. Spacing, I suppose, might have helped. So that is a add. I forget what they call it. But yeah, plus equals means add to the expression on the or the variable on the left-hand side. Which for strings like short strings like these is neither here nor there in terms of time taken. But the bigger your strings, the bigger the overhead of this, because this mechanism here for a string will take a full copy of this and append the given string to the end of it. So you can imagine with large strings, you might be manipulating something which is tens of thousands of characters in a string, in which case this can start to slow down. And strings is not the main problem I see in other people's code, and occasionally see in my code as well, particularly code from many years ago before I learned these things. It's all a learning curve, really. It's arrays. Quite often, if people have got an array. So again, have I got any arrays? Let's have a look. Yes, I've got the files array. So $files, let's see how many files we've got. So I could say $files, which is typically the use case I'll see, plus equals, and again, I force it to an array, and I'll get of a different path, let's say /temp, just the files, but I'm not going to go recursive. And that came out pretty quickly, yeah, because we're dealing with small amounts of data at the moment. Typical data sets can be thousands, tens of thousands, if not more. And so let's see how many files we've got now. I've just added 900. Wow, it's about time I cleared out my temp folder, I think, and that's not even subfiles. So I've just added just short of 900 files to that array. But how that actually worked didn't dynamically add that array to that array. It actually took a copy of that array and then added these items to it. What's wrong with that, you say? Well, again, the larger the array, the more elements, the more data, the slower it will be taking that copy. So what does that mean in practice? Well, we don't necessarily use simple arrays. It is okay for hash tables, though. So if you see a hash table, so again, how do I tell the difference between a hash table and an array? Well, one of the clues is in the spelling, as long as I can spell it right. But we also use subtly different characters. We use curly braces, to define. So that's defining an empty hash table. Let's actually say guy. This is just nonsensical data, but you're used to me talking nonsense. Right, typing nonsense. And of course, I haven't got something right here. What have I missed out? Yeah, silly boy, don't use a comma. So hashy has got one key with guy and a value of that. Let's do hashy 2 of my granddaughter. I know I'm not old enough to be a grandfather or mature enough for that matter. So we've got that table as well. So I can say $hashy equals $hashy. So $hashy has now got both of them in. That doesn't take a copy. That does use an efficient mechanism to add the two hash tables together and set them into that variable. So hash tables, it's fine. Arrays, not so fine. So what alternatives have we got? Well, one way I tend to do things is if typically what you're doing is getting the result of something into an array. So I've given you some simple examples. This far using the ls or get child item. But if we're using more complex ways of forming a loop, let me just find a sample code window. My good old trusty ISE. Let's see, because I've had some problems with VS Code recently, and bring that over. Here's that lovely example I typed in earlier. Here's one from a control up script. So you can see what we're actually doing here is we're creating an array called that vol GUID mappings. Probably should be at volumes GUID mappings. Again, don't skimp on variable names. Make them as meaningful as you possibly can. When I started everything in the old days, writing on Commodores back in the 80s as my first slide had it, then it was typically $A, $B, $C, which is quite difficult to understand what it means. But I only had 3.5 kilobytes of memory to deal with then on my Commodore VC20. I mustn't call it Vic, must I? Because that's something mildly insulting in German. So, oh, I just said it anyway. Sorry. But you can see here what we're doing is we're actually assigning the results of this for each loop to the array. So what does that mean? Well, somewhere in the code, and it's down here, this is outputting the result to the pipeline. In fact, efficiency-wise, I don't even need to do result here. I could just do this. Yeah, so that would output a new custom object to the pipeline, but that then gets added to this array that we're forming. So I don't have to do an add, and I don't have to do a whatever my array is in here plus equals PS custom object. I'm actually assigning the whole result of this entire loop to an array. Yeah, I don't actually need that. But again, this is old code. I'm not sure I even wrote this, to be honest. Oh, and we have a slight scary regular expression there, but it's not scary at all if you know regular expressions. That's just a GUID. But again, I've got a separate session on regular expressions, which I might offer to give you guys. So that's what I mean here by one of the alternatives to plus equals on array is actually assign the results to an array variable. Doesn't help you though if you've already got an array. What if you've already got an array with some items in? Well, again, this is where we'll go on to another way of doing it. Again, I've already told you about this trick of wrapping in the at brackets to avoid array flattening when there's only one item. So if you look at a lot of my scripts on GitHub, again, reference in the slide deck, I typically use one of the generic list objects. Again, this is all from .Net. Again, they're available in PowerShell 7 as well, of some type of object. Now, you could actually just make an object, particularly if they're your own custom object, so it could be a string or an int, depending on what the type of list is. So again, let me give you an example of that. So what we'll do is we'll say ls minus file. Let's create an array first. $array of files equals new object minus type name system.collections. Notice I'm tab completing as well, so you don't have to remember this stuff. Generic.list. Now, because this is a templated type from .NET, it means I have to give it a type of that list. So if I didn't really know what sort of type of objects there were, if they're PS custom objects, I could just literally call it object, and that would work. If I know they're going to be string type, I could give it strings. Now, be as type specific as you can, but a lot of mine are objects, mainly because they're custom objects. So array of files is that. So what I can now do is ls minus file. As I've tab completing that, I'm going to add the item in that loop. $139 files, which is, guess what, same as we did. Oh no, of course I've added the 800 and whatever it was, 900 and whatever from the other folder, haven't I? So yeah, 139 doesn't quite equal 1006. What I've done there is add to the array on the fly. Now, if I had a normal array, as in built-in array, no, that's a hash table guy. And then try doing this again. Normal array. Notice all these errors. Collection was of a fixed size. Yeah, because basically PowerShell built-in arrays are a fixed size. They get created, and whenever they're created, that is the size they are. So you could say normal array plus equals. And that's actually quite fast. Now, because I'm dealing with small numbers, again, 139 files, but that will slow down over time because every time it comes to add, so in this case, 139 times, it has to take a copy of the existing array before adding the extra item to it. So although it ran in a blink of an eye on my 6-core 32 gig SSD laptop, as you start dealing with larger and larger collections, doing this plus equals will slow things down. So this is where you're better off. If I can scroll high enough, would start using the add of this type of object. But if you look, let's, in fact, new object. I don't know if you know about this one, but if you hit Control Space, it's a bit like tab completion, but it will give you a list of everything. So you can see what other types of collection I have. So the one I'd use most of all is a list. I mean, there are hash sets in there as well, but again, there's nothing wrong with using built-in hash tables. I rarely use any of the other sorts of dictionaries available. But you can see we've got sorted lists and various other types of collection. Again, a documentation for these available on Microsoft website. Just stick it into your favorite search engine, just as long as it's not Bing. Oh, and just to note that if you're removing items, because that's one thing you can do with these types of generic lists, is you can remove items. But if you're doing it in a loop, start at the last item and work backwards. Otherwise, things will go wrong. Because if you're iterating forwards and you're removing items, you're going to be referencing items you've removed, and it's going to all end up in a bit of a mess. There is a system that's got collections.generic type itself. I didn't actually mean that. I meant an array list. So not the generic system, got collections.array list. That's a typo in my slide, I think. Find out that. System.collections. Okay, see there's a new object. We'll call it $deprecated. That gives you a little bit of a clue. Deprecated. It's got, hasn't got any items in it. Add. Notice one difference you might not have noticed before, but when I called add on my generic connection, it didn't return an object. Here it returns the index it's added it at. So you would have to assign that to null. Again, I wouldn't pipe it to out null. I'd much rather assign things to $null or cast them to void. If you pipe something through out null, then you've got the overhead of setting up a pipeline. I'll tell you what, why don't I add something different so you can see that we've got different things in there. But this is a not optimized and generally not recommended. In fact, if you go to the link's right, the text is wrong, so that should be system.collections.arraylist. Then it'll tell you why it's no good idea to use it. I used to use it. I don't anymore. I tend to use just this list, templated type generic connection. With strings, the various ways we can avoid using plus equal. Again, if you're using short strings, don't necessarily stress about it, but if your strings could grow to be quite large, the best way is probably using the minus join operator, which takes an array of strings to add. But, don't spend 10 minutes looking at it going, oh, should I use plus equals? Should I? Because of what Guy said about strings. Remember what I said right at the start. Functionality is more important than performance. If it works, it works. Worry about speed later. Okay, so caching data. What do I mean by that? Well, quite often if I'm doing, I've just done a big AD migration script for a customer to take them from their legacy, probably 2008 level domain to a new Azure one. They give me a CSV export of the attributes they want importing. Now I've added a facility to make sure that they're not duplicate names. So what I want to do first of all is, rather than check every name in a loop, so I might be iterating over CSV with 5,000 names in it, I don't want to be running get AD user 5,000 times. What I probably want to do is run get AD user once to get all the names, and then look up in that cache. So if I find a VM, which is, here we go, some of the demos which we'll come back to. So what I will do is create a hash table for the AD users, and then I'm going to call get AD users for all the users. I need to blow those fonts up a bit. Okay, hopefully that's readable. Doesn't still look very big to me. But again, I'm only sat right in front of it. There we go. So what's that going to do? So in this empty hash table, what it's going to do is add the username, which should be unique in my AD, and the AD object. I'm just getting basic properties here. So we'll do that. That's, I've done that. How many users have I got? Well, again, let's have a look. My huge AD, I've only got 50 because this is in my lab. But what I can now, so if we look at $AD users, pipe it through something like out grid view, we can see name it actually is only expanding one of the values. So if I do AD users and look at the first, let's enumerate them all. Select HUV. You can see I've got more detail in there. But the key here is if I want to say, well, have I got a user called, what should we say, Emmy, my granddaughter, I use her. She's my greatest influence on PowerShell, even though she's only one. Have I got user Emmy already? Yes, because in the hash table, we're already there. So if I was writing a script which had read all the existing users in the new domain first and put them into a hash table, so I've called get AD user once, which is way more efficient than calling AD user 5,000 times for each account in the CSV. I cache it into a hash table. Then I can look up in that hash table, which is a pretty quick operation. It's quite slow making the hash table comparatively as a computing the hash is. But then I can do a lookup without having to go to AD. That's the key. I'm not generating any AD traffic, and it's going to be a lot quicker because I can say, if AD users contains this username I've just imported from CSV, then write an error to the error log or wherever saying, oh, this user already exists. So I do a lot of that in my scripts because it's just quicker. So if you know any of the Citrix commandlets, then you might have a Citrix virtual apps and desktops with 500 servers, let's say. It's quite common sort of size environment. I might want to check machines, then I'll get them all in one go and put them into, well, do I put them into a hash table or do I put them into an array? Well, even before we start doing that, we think, well, what's the memory overhead? Remember, we've already talked about loops and things like that, taking CPU, so we can do sleeps or we can reduce our own priority. Well, the same is true of caching of data. If I got an AD with 50,000 names, if I cache all 50,000 in a hash table, how big is that hash table? And therefore, how much memory is that PowerShell session going to take? Now, if you've got a machine with a large amount of RAM, whether that be physical or virtual, then you might be okay. But it might be a case of, well, perhaps you have to use different type of structure to cache that data in, or it might be a case of you don't necessarily always use the full amount of data. So I've actually put, see, the whole AD object in there. What I could do, and again, rather than declaring the array again. I'm just going to clear it. Array, no, that is a hash table though. What I could do is I'll just have $true. So rather than putting a whole AD object in now, I've just put true or false. So if I then go and test if my granddaughter is in that array, it comes back as true. So you can see I'm storing a lot less data in there. One gotcha there is it might be that something you've got in your hash table is there, the key exists, so the key EMI exists, but the data's null, not necessarily for an AD user, but something else. So what the best way to do this is actually to say dot contains key. It's matching. Because if the value that is the key for is null, that will still return true. So you should really be using contains key rather than just that. But it depends on the type of data. If you know whatever the value is for that particular key that you're looking up is never going to be null, then you can use that approach. But if the data may be null or zero, because not will take false or null or zero all as being something that not will return as true, if that makes sense, which probably doesn't. Sorry. So be careful how much memory these things will take. Now, this is something worth noting. The third item, destroy unused data and variables. Now, if you've got a hash table that you're no longer using, if it's still in scope, as in it's still accessible, then yeah, clear it. I just call it a clear method or set it to null, which will mark it as being freeable and the memory available. Sorry, talking myself dry. And if all else fails, use .NET's garbage collector. It might be able to get you some memory back. Don't call it too often, but it can get some memory back for you as well. Possibly not, but don't rely on it. Okay, so that question, well, I obviously didn't do very well on my animations on this slide, but PowerShell I can do a little bit maybe, but PowerPoint, I'm not very good at. The problem that you can get with hash tables, of course, is that the key has to be unique. So if I want to do that, AD users dot add, I'm going to add, let's see if SVC underscore control up is in there already. So it's telling me the item has already been added. So I've already got that item in the key. So what happens if you've got something which has multiple keys, as in it's whatever you're caching, obviously not names in AD, but something else that you're caching, there could be more than one instance of it. Then we can't have it in a pure hash table. So what I will tend to do in that instance is to use a hash table of arrays, so that the item that I have the value for that key actually becomes an array. So if I hit it again, so if I hit that key again, then I will add the item for it to the array. So you have a hash table of arrays rather than a hash table of simple values. Now, another way you can do things is to look up in an array. So that might be faster, particularly for shorter arrays. If you've got an array of 10,000 things and the item you're looking for is at the end, and you use a where object or a .where method, as we talked about on an earlier slide, then it could be that because it's not matching till right near the end, that it's going to take a long time. So do you sort your cached data in your array? We can't sort things in a hash table because they're keyed on the hash, but do you sort the array contents such that your most commonly accessed, commonly found things are near to the start? But again, you've got to understand the data to know whether that makes sense, or could the data just be anywhere? Yeah, and sometimes that some things I will do a test of a hash table versus an array for the type of data I'm using to see if there's a marked difference in terms of massive difference in runtime between the two, because most of the time it's quite quick to code something as a hash table or an array for this data caching and compare the performance. Mostly I'll use hash tables because they're just cleaner and easier. And I just don't like lots of iterations, you know, a .where every time you need to look something up in an array. But hash tables can be slow. It will depend on that number of elements. And we've already talked about I've already talked about the .where versus the where object. As we saw, it can take an account. And this is what I meant about the reference. So if you put this into your favorite search engine, the where operator selection mode, that'll tell you about the last and first and until and other enumerations allowed. So you can mimic the select object. Because what we want to do with the .where is make sure that we don't search the whole array. So that's one advantage of using a .where without them piping a where object through a select object. Is, you know, if I say .where, (1), then it'll stop as soon as it finds the first match. So it finds the first match in the first 10 out of 10,000, then it will stop. It won't look at the rest of the 10,000. So that's another good reason to use .where method. Caching commands. This is not needed very often, but you probably don't think about it when you run a PowerShell commandlet or function, is that PowerShell has to know where to find it. So how does it know? It's going to look through all your imported modules, which it will generally cache in a file or files in your local Windows profile or in your Windows profile. And if that's persisted, that will be persisted across sessions. But if you don't tell it exactly where to find that, and I've seen this with logon scripts which use PowerShell where I've not explicitly imported the module that I've needed, that it's taken 15, 30 seconds or more to run that particular commandlet, because it has to find it. It has to basically say, oh, look at all the modules that are available for my user. Is that commandlet available in those modules? Whereas if you explicitly do an import module of that module where the commandlet is, then it will know to look in that module. Or you could even, as the last example gives here, what we call module qualify. So get-vm is there in VMware PowerCLI, their PowerShell SDK, but also for good old Hyper-V. Both have get-vm. Which one am I going to call? Well, one way to make sure is to actually domain module qualify it, like I have done here. This really comes into its own when you're in a loop running something thousands of times, because what you don't take into account is the lookup time. But each time you're looking up that command, or each time the script's looking up that command on your behalf. So what we do is we get that command with get command or GCM, the alias, and then we can call it with dot or ampersand call operator. So again, let me give you an example of that. Well, let's say we were doing get AD, we were using get AD user in a loop, which I said is a bad thing, but I'm just going to use it as an example because it happens to be here. So what I'll do is we'll say, let's just resize that so I don't have scrolling issues. So $AD get AD user equals get command -AD user. $get AD user. We'll see it tells us about the command. Yes, we've not invoked it. So what I can do now is I can do $get AD user. Notice tab completion isn't working for me. So that's one downside of using commands in this way, is that because it's indirect, we're not getting tab completion. So you have to know what your command line options are, or of course you could just change that to get-AD user. Do your tab completion star. In fact, we'll say equals any. If I can type, fine thing. Yeah, filters. Okay. Does that work? No. Oh, don't you love those live demos? Is it minus identity? Yeah, spelt the German one. Yeah, there we go. So got there in the end. So I'm getting the same result now by calling that, because that is, as we saw earlier, is my command. So I've cached the command so that when I .invoke it, it's going straight to the command. It knows exactly what the command is because it's got the command there. It doesn't have to basically search the environment and all the modules for something called get-ad user. Depending on what order the modules have been loaded in and so on, it could take a small amount of time. We're only talking milliseconds, but if you're doing that in a loop 1,000, 10,000 times, that can all add up. The number of times I do this is very small. The last time I did it, I was working with some ETL files, so a whole load of Windows events from some tracing, calling various commands. So it's a very, very specific use case. So I don't use it very often. How are we doing for time? Oh, okay, time is pressing on. Parallelization. Yeah, even English can have long words. So what I mean now, can be things run in parallel. Can I run several things at the same time? So can I split them into separate, unrelated activities? It's no use if I need to take the output of one task to pipe into another. It wouldn't be any use necessarily doing that in parallel. But one that I had great success with a few years ago was getting some details on some Citrix machines, again using the Citrix PowerShell SDK. 200 plus machines. When I did it sequentially, so machine 1, machine 2, machine 3, it took 15 plus minutes. But because I was getting all that data and then processing it, I actually found some code to make it run in parallel. So using something called run spaces, which aren't actually that tricky, particularly when you get the hang of it. It's quite easy. I'll show you some code which you can quite easily copy and paste and then just add your own code to, so that I could effectively not necessarily launch 200 parallel threads. You could actually got control over how many parallel threads you allow. It might be 20. You might match the number of cores you've got, but some of those tasks threads may pause, so it might be worth adding more threads. But we can run that stuff in parallel, bring all the results together, and then process it. And that improved the script runtime by a factor of about 10, because I replaced that sequential processing with parallel processing. But it's only specific types of things that can be done that way. Now, if you've got the luxury of being able to use PowerShell 7, then you can use for each minus parallel. Sorry, there should be a space in there. So I can do, where's my Windows terminal? Lost it. Careless of me. Here we go. Too many windows. So this is it for each object? I did say I don't use it often enough. Yeah, so there we go, for each object minus parallel. Sorry, so the two typos in that slide when that 1 point. So the loop I give it here will run whatever script block in parallel. That can help you greatly in PowerShell 7, but for those of us who are still forced to use PowerShell 5, if we're lucky, we have to use other techniques. So one little known fact is the invoke command built-in commandlet. When it takes minus computer name, the computer name is a list, an array of machines. So what I can do there is, if I wanted to do commands on 3 different machines, then I could specify those 3 machines separated by commas with the script block, and it would run all those in parallel and give me the result back. But it does need remoting configured. And of course, what I could do is use localhost, which I think I've got an example of here. Oh, let's bump the script fonts up again. No, it's font guy, that'll be useful. So again, using search history. So look, let me actually type. There we go. So the guts of the command, I've wrapped it in a measure command so we can actually see how long it takes, is I'm going to run on 3 instances, all on my local machine, and I'm going to sleep for 10 seconds. So if these were run sequentially, that would take 3 times 10, which I believe is 30. Whereas if it does run them in parallel, like I've claimed, then it will only take about 10 seconds plus the overhead of the invoke command, plus the overhead of measure command as well. So let's run that. Count to 10 or thereabouts. 10 seconds is a long time when you're waiting for a script or immediate commands to come back, but hopefully that will come back at about 10 seconds. Yeah, so we can see that's taken just over 10 seconds. So that proves that it runs it in parallel. But the downside to that, which I can prove in this one, is that remoting needs to be set up and you need to be a user who's got access to remoting. So like a sensible person here, I'm not running as an admin. So for instance, filter manager, driver control program, which is a good way of testing whether you're admin or not. Access is denied, whereas in this one, it's allowed. So I'm an admin in that one. So if I try the local host thing in this one, yeah. Oh, look, it only takes 0.06 seconds. Yeah, because it's access denied, because this is, even though it's localhost, it's trying to remote. So the invoke command way of parallelizing things in PowerShell 5 or earlier is, yeah, not fantastic. So the best way to do things is to use run spaces. And run spaces, if you've ever looked at them, yeah, people think they're big, scary, horrible things. They're not. What hopefully I've got as an example here that won't scare you at all. And not that one. This one, a new script that's coming to control up soon. So the guts of the code is actually quite simple. It's on the screen here. So basically the run space pool, we create it, configure it, we add to it, we run it, and then we get the results back. So again, this is code. I forget where I got it from. I will originally have given some credit to where I got it from. You can see here I've got credit to something else. It's not for getting the output from the run spaces. It's typically the way people run spaces is wait for the output at the end. What I'm actually doing here is getting the output while the run spaces, so the threads are running. This is, well, as the name suggests, it tails, so it gets the ends of event logs. So this the script coming soon to control up, which will, you can point it at any number of different machines, and it will do a live display of the event logs from all those machines in a single view as they happen. So quite useful for logons of Citrix or VMware or whatever, so you can monitor storefront and Citrix servers and delivery controllers and so on. So basically we create a run space pool. Here's the parameter that tells us how many maximum in parallel we're going to have. So I actually say, well, the total number of computers I'm going to operate on. We give it a session state, which I've just created up here. We give it a PS host. Again, don't worry about the implementations of that. We actually open it. I create, this is just a collection of outputs. Notice I've got a bit of timing around that. I create a PowerShell instance and set, so this creates a PowerShell instance. So this is me being a bit terse with my code. Perhaps I should have split that into multiple lines. PowerShell equals PowerShell create, and on the next line, $PowerShell.run space pool equals run space pool, but that's doing it all in one. So I've created a new PowerShell run space and a new PowerShell object. The thing I didn't say was you do have jobs. You can use job objects. They're built into PowerShell, but they create a brand new process. So the overhead of that can be quite high. It can take two or more seconds to create a new PowerShell process and then tear it down afterwards. So I tend not to use jobs for time critical things, but jobs do have their place. We add some script. So again, don't worry about what's in the script. You can see there's 40 odd lines in there, but again, it's just a script block. Typical normal PowerShell code. Take some parameters because we have to add the parameters. This is how we pass parameters into that, what's going to be a remote thread. So there's me setting the parameters. And what we do here is the jobs is actually my list of, so you can see here, it's one of my generic lists that I'm doing, generic lists that we talked about earlier, an empty list. So I'm keeping a note of all the jobs that I'm creating. Again, not proper PowerShell jobs, but I call them jobs. Yeah, they're threads effectively. So I create a custom object in here, and this is the magic bit. This tells the thread to start and where to put its output. And the line that actually reads all that is that. And so that one line there will get all the event logs from all the machines in the specified period and display them in a, well, put them to the output, and then you get the pipeline, and you can pipe them through out-grid view. So we, just to reiterate, we create a run space and open it. Again, next time, I just copied this from my previous script that used it. We create a PowerShell object, we add a script, we add parameters, we invoke it, and then what I do down here, because this is live output, when that finishes, because this will finish at a specific time, because I tell it to run for 5 minutes or something like that. Then all it does is go through and just check all the jobs are definitely stopped, just in case something's hung for whatever reason or didn't finish. And you can actually then go and fetch the errors or any verbose output and output them as well. So I say it's easy. If you've got an example bit of code, and again, that's how we, come on, that's all how we write PowerShell, isn't it? Has somebody done this before? Yes. Let me go and get their script, give them some credit, see if I can improve it. If not, I use it as it is. Yeah. Why? Yeah. Reinvent this wheel thing. If somebody's already done it, no point doing it again. But if you do take other people's code, particularly if you're going to run it in your live domain with 10,000 user accounts, make sure it's not accidentally or deliberately malicious, as in it's not going to wreck your domain. Then when we've finished all the jobs, we just tear down our run space pool again, just to be tidy. And that will just, for all the computers here, we'll just go and get all the event logs in real time. So I could have 10 or 20 different computers, and they're just one line brings them all together. So that's a great way to do this sort of thing. So run spaces, I love them. Less of a need in PowerShell 7 because we've got the for each object minus parallel. I'll correct that before I put the slides out. But run spaces that I still use in PowerShell, Windows PowerShell version 5 and earlier work great. And that's kind of it. Some references to various things I've talked about. The next slide is questions. If you have any questions about the content or stuff I didn't mention, again, it's kind of a whirlwind tour. And my kind of best practice is being somebody who writes PowerShell pretty much every day, weekends included. But yeah, if there's any questions, I see there's nothing in the chat. That's probably because you've all fallen asleep.